Good evening, everybody. And first, I thank these organizers of Quark'17 for inviting me here. And I congratulate them also for holding this grand fest, and which is a lot of innovation. And we saw one flashes of innovation. In fact, this was a mind-blowing show. This snake charmer, bagpiper, never heard of such a thing. And it was very, very impressive. And only my fear is that after that, our scientific talks may sound very drab, very mundane, but can't help it. And I'll start my brief 20-minute tour of the universe. So at the end of it, maybe we'll see whatever we know, take for granted gospel truth. They may not be true. And incidentally, that has been the way I have carried out my research, particularly in the last 15, 16 years. So talking about universe.
Excuse me, sir. Can I adjust your mic?
Yeah, please do. Okay, thank you. Thank you. So talking about universe, our stepping stone, is solar system. Our planet, Earth, is rotating, revolving around the sun. And with a speed of almost 30 kilometers per second, and it takes 365 days, that makes 1 year. And beyond that, there are many stellar clusters, star clusters. Most of the signs of zodiac are named after particular star clusters. And beyond them also, then we have our galaxy. Many of you know it's called a Milky Way galaxy. It's huge, much huge. And we are situated somewhere in the midway of the Milky Way galaxy. There are around 100 billion stars in it, apart from many other exotic things, a lot of gas, dust, and many exotic things. And at the end of the talk, I'll be talking about one exotic thing called black holes. And to see how vast is this galaxy, our Earth is revolving around the center of the Milky Way. And it takes how much? Around 225 million years. 225 million years to make one revolution around the center of the galaxy, and this is called a galactic year. And if we go even beyond it, then we have many star clusters. This is our local galaxy. We have two main galaxies. One is our galaxy Milky Way, and then we have something called Andromeda galaxy. This has appeared in fact, many science fiction also, Andromeda galaxy, and there are smaller galaxies. And beyond it, there are lots of many superclusters of galaxies. In fact, we belong to a supercluster called Laniakea. And when you go beyond it on the largest scale, you have superclusters all over the universe, and they do not come uniformly. They come in a spider-like web kind of thing, and it is called cosmic wave. Mostly they are in the filaments and in the walls, and in between there are what is called voids. And universe is mostly dominated by voids. Void means there is very little matter, very few galaxies, they look mostly dark. So unlike what we know, the universe is smooth, actually it is very strange, this spider web-like character. And mostly it is voids, and on the surfaces there are waves, filaments, where the supercluster and most of the matter reside. And now I'll be talking about one thing before going to the cosmology. So when we study the spectrum of distant galaxies, we have something called redshift. Redshift means we know, suppose this is the hydrogen spectrum. Various frequencies lights come. But when distant galaxies, this line seems to be shifted towards the red. So physically, this means whatever photons are coming. Photons means corpuscles of light particles. They are losing energy. And this is called redshift. In principle, this redshift could be because of various reasons. So one of the reason could be Compton effect. Compton effect is high energy electron photon is interacting with a lower energy electron, and it may lose energy. There are many other ways light can lose energy, and there could be redshift. But the best way, which seems even now the best way, is something called Doppler effect. So Doppler effect you experience when you were on a railway platform and some engine is approaching you. When it is approaching you, your relative velocity is more, and that engine, whatever its sound is very shrill. It is pitch is higher. Actually, frequency increases when it approaches you. But when the engine is receding, then the sounds look quite pale and drab. Then the pitch decreases, and basically frequency decreases. Similarly, for light also there could be Doppler effects, frequency decreases. This decrease in the photon energy indicated by the redshift was interpreted this way in terms of redshift. That means that distant galaxies are receding away from us. So every observer, we also assume that every observer sees the same thing. So this is the picture which emerged, that every galaxy, we are sitting our Milky Way galaxy and we see all other galaxies receding away. Similarly, Andromeda also sees all other galaxies receding away. And this gave rise to a picture, everything is receding away. Then if you interpolate back, then something must have started from a point. And this point is called Big Bang, out of an infinite explosion. This is the Big Bang. Then since then, galaxies are expanding and new galaxies are formed. And this is called, there is a lot of support in this. Is a beautiful theory, a lot of support. But problem is that here, how did it emerge? It came out of nothingness. This is a deep philosophical paradox. How you can have things out of nothingness, massive violation of conservation of mass energy. Despite that, there are many positive things. But there are also many contradictory things as we have newer and newer telescopes are coming. There are Big Bang problem is facing many challenges and many contradictions. So one of the things is this. When you have an explosion, I said Big Bang is an explosion, you expect the fragments to slow down. They to decelerate. You see that everything, Diwali fragments are slowing down. So this is what was believed 20 years back, that the universe is expanding, it is slowing down. But after 20 years, for the last 2 decades, the new paradigm emerged. No universe, some observations are there, the universe is actually expanding. But how can somebody expand? It should slow down. So one hypothesis was made, it is called dark energy. That dark base, we do not know what sort of energy this is. But this is considered some repulsive energy whose original idea was given by none other than Albert Einstein in 1917. It is called cosmological constant. As if in the space built in some repulsive properties there, which is anti-gravity, which try to expand things. So that is what is used in explaining this dark energy. And apart from dark energy, also there are other problems, other assumptions in the Big Bang. So presently, the Big Bang model, whatever it's called, it has very strange composition. So we see galaxies, stars, planets, and they are made of atoms. Atoms are made of neutron, proton, electron. This is the normal matter. But as per Big Bang model, all this normal matter, whatever galaxies, they constitute barely 5%. And this dark energy, what I told, the mass energy, that contributes more than 70%, and about which maybe 10,000 papers have been written, but we do not know. So many mainstream cosmologists now think that dark energy may not be real. So Big Bang model assumes the universe is very smooth and homogeneous, but as I showed, it is not so, it is lumpy. There are star clusters, there are galaxy clusters, there are voids, which is different from the assumption of Big Bang. And now there are proof on the larger scale there are inhomogeneities. So many mainstream cosmologists think that Big Bang model is simplified, and this dark energy is an artifact of explaining a complex universe in the paradigm of a simplified model. That about dark matter is even very strange. So 20% matter is not dark energy, but still 24% we cannot see. Not only we cannot see, their Big Bang has some constant, they want to be strange particles. So they are not made of neutron, proton, electrons, very exotic things. And all the big experiments for the last 20 years have been looking for it. Large Hadronic Collider, there are gamma ray telescopes, X-ray telescopes, underground experiments. Many theories have been predicted, but nothing have been found. So Big Bang is in a big crisis. One of the main pillars of Big Bang, this dark energy has almost collapsed. And as I told, dark energy also has problem. But while most of the many leading researchers have told that dark energy may be illusion, I might be the only researcher who has shown that dark energy is impossible in a fundamental way theoretically. I said it could be Einstein's cosmological constant, and a series of my papers starting from 2010 have shown from various ways that Einstein cosmological constant is identically zero. So the main candidate for dark energy is zero. This was one of the main paper which came in Nature Scientific Reports and before in 2012. So it showed that if you have dark energy, there is a fundamental inconsistency in general relativity. And then this is another paper by which I tried to show that dark energy should be zero. There are two other papers I am not showing. And this is my last paper. I actually superannuated last year. This is last paper in a leading journal, monthly notice of Royal Astronomical Society. And the implication of this paper is that actually Big Bang model, all the mathematical model, so it assumes that something is expanding homogeneously and isotropically. So every observer seems the same picture and everything smooth, homogeneous. That is not possible. That is possible only when there is no matter, it's all vacuum. So it means that actual universe is different from the Big Bang assumption, and which is what we see. It's lumpy and something inhomogeneous. But what is the true nature, we do not know. So here is just a quick view of this thing. And there are many indications that Big Bang universe could be static also. This is a 2015 review paper. And you see there are two columns. One is for static universe, one is for Big Bang universe. If you see the static universe, there are more positives. I mean, more parameters support the universe could be static. This sounds incredible, but it might be true. So science has gone through various paradigm shifts and unexpected surprises. Maybe something is around the corner. And as I told, whether my research, they have not made that kind of impact which it should have done, but still some people have taken note of. Last year, one paper was published, and I said my Nature Scientific paper. So it was referred as Mitra paradox, which told that there is a fundamental paradox arises if dark energy would be there. And there's talking about our universe, there are many, most exotic thing is black hole. You have heard this name. So it means something which is gravity is so strong that light cannot escape. Yet, paradoxically, ironically, black holes are supposed to be the source of all the energies of the universe. We see a lot of radiation. Sun is nothing ordinary optical light. We see things coming in X-rays, radios, gamma rays, and biggest explosions, they're all attributed to black holes. So black holes, because of their gravity, they pull their matter around them. That matter heats up, and by friction, radiation is produced, and also surrounding magnetic fields are there. That is what the prevalent theory. And sometimes jet is also found to be coming out of black holes, but they have no magnetic field. But how jets can come out? And ideally, although we showed this kind of picture, ideally it comes from in 1916, Einstein formulated his theory, general theory of relativity, single point. The simplest solution, black hole solution, came from the mathematical solution of a single point. And this red line is an imaginary red line. So anything falling within it, gravity is so strong, cannot come out. And this has many peculiar features, very funny things. They say inside, space becomes time, and time becomes space. Mathematically, one can say physically nobody understands. Einstein did not understand. He did not believe in black holes. Sir Arthur Eddington, biggest theoretical astrophysicist, he did not believe. Most of the fathers of relativity did not believe. But slowly mathematicians took over, and it became a big paradigm. In 1939, two Americans, Oppenheimer and Slider, actually showed Einstein equation and claimed that you have, in real universe, stars may collapse to form black holes. But they made a lot of simplifications. That they set the pressure zero. In realistic cases, we have never pressure zero. In fact, anything which is contracting becomes hotter, and pressure increases. Now, this is considered the basis. Now you see in the same paper, Physical Review, very famous paper, just what this authors told. The further a star in early stages of development would not possess singular density. Singular, the point is singular, density is infinite. Or pressure, it is impossible for a singularity to develop in a finite time. This is what they wrote in the paper. They are very good physicists, but they are compelled to use that simplification pressure zero. Otherwise, these equations cannot be solved. Einstein saw this. He did not believe, but most of the mathematicians ignored it. So black hole paradigm was built. One paper came in 1969. It's a famous journal, Mathematical Physics. And here, just see the keyword. New point of view is presented. It's a point singularity. So I said black hole is a red circle. It's a sphere. How can it be point singularities? A sphere becomes a point when the radius becomes zero. It is shrunk to a point, radius is zero. And radius zero actually means mass is zero. In relativity, it is possible that mass is zero. It means sources of positive energy, heat, internal energy, rest mass energy, these are all positive energies. But gravitational energy is attractive, that is negative. So when gravitational energy increases, mass decreases. And in principle, it is possible that at the end of the collapse, entire thing, they are equal. The negative thing offsets the positive things. And this is what this paper suggested. But it was not taken seriously, very seriously that time. And this is in famous journal, Physical Review later. And here also these authors just see the point singularity they are telling. So how can a sphere be a point singularity? And if it happens as point singularity, the black hole paradigm actually collapses. But again, it was ignored. So what happened then? I was working actually theoretical astrophysics and something called gamma ray burst. On the theoretical thing, I think I was the pioneer in India. In fact, my first paper was cited 1995 by Sir Martin Rees, who was a speaker, guest speaker here last year. That is why I feel very happy to talk here. In gamma ray burst, I tried to solve the problems, and by 96 or 97, it became clear that gamma ray bursts are the biggest explosions in the universe. But then how to explain them? There is no theoretical paradigm. Before that, it was believed the black holes, if the star is collapsed to a black hole, not much energy will be released because nothing can escape from black holes. But then 97 people started talking, maybe black holes are responsible for gamma ray burst, but I did not accept it. So I did my introspection and my own study, going out of the mainstream, because mainstream, whatever they have their own prejudices. I also had that prejudice, but I overcome it. And to cut a long story short, this was the first paper Einstein tried to show that black holes are not there. He could not prove. Eddington could not prove. This was the first paper peer-reviewed which claimed that black holes cannot form in a fundamental way. It was in a journal, Foundations of Physics Letters. This was the first paper. Then there was other papers. There was another paper in 2002. And what we showed, I predicted that your so-called black holes are not point. Like sun, you have a lot of fire, lot of charged particles, plasma, it is called magnetic field. So-called black holes are strong magnetic fields. And this is the way I predicted you can distinguish between whatever I am telling or black hole. Because black holes are point, they don't have any magnetic field. So, and this proof came in 2006. So some American colleagues started working on it, and they offered proof that one of the famous so-called astrophysical black holes has probably magnetic field-like structure. And because this was so important, the Harvard University had a press release on it. And this is not to take pride, I am actually do not take pride. Post-independent, whatever theoretical astrophysics, and maybe other physics, no research has carried out purely in India, which has been the content of a press release for either by Cornell or Harvard or by Cambridge. They ignore Indian science mostly. So this happened. And there also my name came only in a minute way, very minute way. I told my American colleagues, you have only given 1 or 2 lines when I gave the original idea. They said our press officer is not ready to put the name of any Indians. And with a lot of difficulty, I inserted just your name. And what I told that actually your so-called black holes actually is ball of fire. And then there are more proof about that most of the astrophysical black holes have magnetic fields. So these are some of the proof. This was the proof, 2006 paper. This was 2008. And there were other papers. And before that, in last year, 2014-15, these are the top journals. Now they find most of the so-called black holes, there are strong magnetic fields, which is unexpected. 20 years back, nobody would believe. Of course, so and this actually substantiates whatever I am telling you, black holes are not black holes. They are ultramagnetized objects who surrounding you naturally expect black hole magnetic field. And then you can explain a lot of the radiation and even the jet I showed. Not that these authors take my name there. Now this is our closest thing, sun. Now whatever we think sun, actually it's a ball of fire. Fire means it is charged particles. And whenever we see an ordinary candle flame also, there is a lot of charged particles that gives you the light. And sun is much more stronger fire. And there are long local circulations, charged particles are moving magnetic fields. When you have plasma and magnetic field, you have very strange things. Sun is always emitting winds. It is always in a turbulent state. So this is a simulation for a flare. Lot of flares and fire is coming out in a burst. Sometimes you have coronal mass ejection and terrestrial inter-telecommunication get disturbed. So much charged particles are emitted by sun sometimes. So I told the black hole candidates look much more turbulent. Actually, they should have been much more quiet. I said because they are actually balls of fire, so that is why your flares are taking place. And some sort of direct evidence came in 2015. NASA had one telescope, NewStar. Now, from black hole flares are seen, they are far away. But NewStar had very good resolution, and it found that this flare has come. This flare has come because something, maybe some coronal mass ejection has taken place close to the black hole. But this is not allowed. Black holes cannot have emission. So it became a big science news. And also I was interviewed by Nature India. I told what they are saying is not a black hole. It's whatever I told. The ball of fire, sun is a magnetized ball of fire. And this news also spread like wildfire all over the world. And now you will be telling that, okay, last year they detected gravitational waves, and they are claiming it's all black holes. If I had interaction with the entire, so only Indian who can have interaction with the entire international team. They are theoreticians. I told them, whatever you have done, you have detected, I salute you, but you have not detected black holes. So initially they tried to make noises, no, your things are not. I said, this is my paper, you give a rebuttal. And I have shown the exact black holes has zero gravitational mass. They cannot be black holes. And I had 3 email correspondents, last was 4-month-old, they could not respond. Now this was on February 15. After 2 months, there was a paper in Physical Review later. So 2 Spanish theoreticians did numerical calculation, and they told, yes, whatever they are claiming from black holes, it may not be black holes. It may be quasi-black holes. Of course, they again did not take my name, but at least after 2 months, there was a paper that it need not be black hole, it could be quasi-black holes. So I will end my story here. So thank you for listening with patience.